નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Dear students, good morning. We had a talk for chapter number 8, Trigonometry. Now using these trigonometric ratios and identities, today we are going to talk about applications of trigonometry, heights and distances. In this, before we start the chapter, here we have to go for some of the terminology of this, that is angle of elevation and angle of depression. Angle of elevation and angle of depression. So let us see. Now you can see here there is a right angle triangle. Here this point is point of observer. So here the observation of the object at B could be seen, and OA is the horizontal level. Here it is a horizontal level, ground level, parallel to horizontal ground or horizontal level. Now we are observing the point B. So this is called line of sight, and this is called horizontal level. So here angle of elevation is the angle formed by the line of sight and line of sight with horizontal level. So when point being viewed is above the horizontal level, this point which is viewed is above the horizontal level. You can see here observer, this is horizontal level, this point which is being observed is above the horizontal level. So this angle AOB, this is angle theta, is the angle of elevation. Similarly, here angle of depression, you can see here AB, here it is a ground level, and OC is a horizontal level parallel to ground, and this point is point of observer, and this is here the point of sight, or this is the object, we say here object. Now this line is line of sight. From this point the observer is observing this object. Here the point which is being observed is below the horizontal level. You can see this is the horizontal level, it is below the horizontal level. Here it is above the horizontal level. Here you are observing top. So here angle of depression is the angle formed by the line of sight. Angle formed by the line of sight with horizontal level. So when the point which is being viewed is below the horizontal level. So here angle OBA, this angle is equal to angle COB. These two angles are equal because they are alternate angles. So that is equal to theta. So this angle, actually it is the angle between horizontal line of sight and the horizontal level, that is the angle of depression. Here you can see for angle of elevation, here the object, for example there is a tall tower. You are observing the top of the tower from point O, that is at a distance O equal to OA from the base of the tower. This is the base of the tower, is the top of the tower. You are observing the top of the tower from this point. So you are observing this, it is, and this OA, base of the tower, and where you are standing, this is called the horizontal level. So you are observing the point that is above the horizontal level. The point which is being viewed is above this horizontal level. So this angle formed between line of sight and this is called angle of elevation. Now angle of depression. In this angle of depression, what is there? Suppose you are observing from top of a building. You are standing at the top of the building. OA is a building. You are on the top of the building, and this is the base of the building, and there is a car standing on the road little bit away from the base of the building. You are observing the car. So here the car, where it is, the object which is being viewed from the observer is below the horizontal level. This is the horizontal level that is parallel to the ground. So this is a horizontal line. So horizontal level, and this is the line of sight. So this object car which is being observed is at the is below the horizontal level, and you are on the top of the building. So this angle is equal to this angle. They are alternate angles. This angle is called angle of depression, but these two are alternate angles. So for this triangle, this is theta, is angle of depression, and here right angle. So we can make use of trigonometric ratios and identities to solve this. So this way we can apply this trigonometric identities and ratios for heights and distance. So let's start now illustration for this applications of trigonometry. Now illustration 1. In illustration 1, here there is a tower AB. So let AB be the tower and C is the point of observation. We are observing the top of the tower A from C, which is a point of observation that is at the base, or B is the base of the tower and this is the ground. So BC is the ground level, that is a horizontal ray. This is the ray of sight, and we are observing point A, which is at a height of H, and C is the point of observation at a distance of 15 meter from base. And the angle of elevation, ray of sight and ray of horizontal ray, so angle of elevation is 60 degree, that is angle ACB 60. Now question is to find height of the tower. So height of the tower is opposite side to the angle 60 degree, and this is the 15 meter distance is the base. So opposite side and here base relation is, we can go for trigonometric ratio, that is 10. Tan theta is equal to opposite side upon base, and therefore we can say, now in triangle ABC, angle B is a right angle, angle C is equal to 60 degree, therefore tan 60 is equal to opposite side upon hypotenuse, opposite side upon base. Now tan 60, what is tan 60? Tan 60 is equal to 1 by tan 30 is equal to 1 by root 3. Tan 60 is equal to root 3. So we have to remember the trigonometric ratios. AB is height that we have to calculate, and BC is 15 meter, and therefore we will get H is equal to 15 multiplied by root 3 is in meter. But now root 3 we can't write. Here we have to convert root 3 value. We must remember. So we can go for that also. This is meter. We can write this answer. But sometimes whenever it is asked, we can convert root 3 into root 3 is equal to 1.73 meter, and therefore we will get the height is equal to 15 3s are 45, carry 4, 15 7s are 105, 105 and 409, carry 10, 15 1s are 15 and 10, 25. So 25.95 meter is the height of the tower, is equal to 25 point, that is equal to 25.95 meter. So that is 15 root 3 meter. But whenever it is asked to convert, if we know root 2, root 3, we have to remember this value. Root 3 is equal to 1.41 we can take. Root 3 is equal to 1.73 we can take. 1 by root 3 is equal to 0.58 we can take. Root 5 we can take 2.236 we can take. That is approximately we can take 2.24. So now same way one more question is here, illustration 2. Here it is, electrician has to repair electric wire, electric fault on a electric pole, and that is of height 5 meter. So here electric pole is of height 5 meter. Let AB be the electric pole. Let AB be the electric pole such that AB is equal to 5 meter. Then we need to need to reach a point 1.3 below the top of the pole. Has to reach 1.3 below the top of the top. Say here this point we say C. This total height is 5 meter and has to reach 1.3 meter below, that is point C, 1.3 meter below the top of the pole to undertake the repair work. Here she is to reach here. She is to reach here. Now, what should be done to with the length of the ladder? What should be the length of the ladder so that we here she should use which can be inclined at an angle of 60 degree. Here this ladder, there is a ladder. Here say DC is the ladder and that is inclined at 60 degree. Okay, so ladder is inclined at 60 degree here. You can see 60 degree. Okay, CD is the ladder and it is inclined at 60 degree and reaches at point C, which is 1.3 meter below the top of the pole. So here our question is how far. Also here after finding this what should be the length of the ladder, what should be the length of the ladder, that is what should be CD, so that she can reach at the point C and the ladder is inclined at 60 degree to the horizontal level. Now would enable her to reach that position. Then how far the base of the ladder also, how far, what should be the distance foot of the pole from the place of the foot of the ladder. And here we have to take, it is given in the question that root 3 is equal to 1.73 we have to take. So here what we have to do, here you can see now AB is the electric pole such that AB is equal to 5 meter and D is the base of ladder such that here base of the ladder is such that angle CDB is equal to 60 degree and it touches the pole at C, where AC is equal to 1.3 meter and therefore here BC is equal to AB minus AC, that is 5 meter minus 1.3 meter, 5 meter minus 1.3 meter, and that is equal to 3.7 meter. So this is 3.7 meter. Here we know this, so we have to calculate these two parts. So first of all, in triangle BCD, in triangle BCD, angle D is equal to 60 degree, and therefore to find out this BD we can go for 1060. Here 1060 is equal to, therefore 1060 is equal to opposite side BC and base here BD. So we will get here, what is this, 1060 is equal to root 3 and BC is equal to 3.7 divided by BD is not known, so we have to calculate BD, and so we will get BD is equal to 3.7 multiplied by root 3. So here it is in meter. We will calculate the root 3 value. Also we have to calculate this. So first of all, let us proceed for this. I am rubbing this part, here we are solving. Now we can see we got BD is equal to root 3.7 multiplied by root 3. Now we have to calculate, that is what, here it is base, or we can say base of the pole away from the base of the ladder. Okay, now let us proceed. Here BD is equal to here you can see BD is equal to, it is in 3.7 divided by root 3 meter. Now we can calculate how, root 3 we have to calculate here, that is, therefore BD is equal to 3.7 root 3, we can rationalize the denominator, rationalize the denominator, multiplying both this numerator and denominator, will get 3.7 multiplied by root 3 divided by 3, and on simplification here we will get 3.7 multiplied by 1.73 divided by 3. So this is will get approximately 2.14 meter. This is approximate base. Round off, we have to take this value. Now also we want CD. Now what is the relation between the CD? CD is actually hypotenuse and this is opposite side. The relation between hypotenuse and opposite side is sine. So we can take now sine 60. Sine 60 is equal to, what is sine 60? Sine 60 is equal to root 3 by 2. So now sine 60 is equal to, here we will take opposite side, that is BC upon hypotenuse, that is CD, with respect to this figure, and therefore sine 60, as I told you, root 3 by 2 is equal to, here BC is equal to 3.7, and divided by CD, we want the length of the ladder, and therefore length of the ladder CD is equal to 3.7 multiplied by 2 divided by root 3. Again we can rationalize the denominator, multiplied by 2 multiplying by root 3 on both the sides, we will get both numerator and denominator, we will get CD is equal to, here 3.7 multiplied by 2 multiplied by root 3 divided by 3, and so here we will get this is equal to approximately 4.28 meter, that is approximate value. So this is the length of the ladder, and here it is distance, that is between the base of the ladder and the base of the pole, and here it is length of the ladder. As you can see here, as it is 60 degree, this is 30 degree, so here hypotenuse is double of this. Here we got 2.14, so here we will get 4.28. As it is 30 degree, side opposite to the 30 degree is half of the hypotenuse. We will get this shortcut also, we can verify this type of questions. Now illustration 3.
Thank you for joining us.